So the last part of Unit C, we're going to take what we've been doing so far and try and apply it to solve some hypothetical real-world problems. I don't know that these will ever be our real-world problems, but in the idea of business having, minimum orders or production capacity or maybe challenges in meeting payroll and these kind of things, we can graph or we can model reality into equations and then graph those to see what the options are for a business or a situation to operate. And so that's really what we're talking about here. We're going to carry on with these inequalities, but we're going to apply them to some real world things. So for an example, you are a chef and you use potatoes to make fries and mashed potatoes. You have to make at least 20 servings, but you have this difference where fries use 1 potato, but mashed potatoes use 2 potatoes. We only have 30 potatoes available. So there's a minimum number of orders and there's a minimum number of potatoes. And then we have this function that fries take 1 potato and mashed potatoes take 2 potatoes. And so what we're going to try and do is translate the problem above into some kind of inequality statements. So we're going to start off by saying, okay, let's fries represent by X and potatoes represent for Y. So what we're going to do is end up with a graph with fries on the bottom, number of orders of fries, and mashed on the y-axis. So the first constraint is that we need at least 20 servings. So the servings of fries and the servings of potatoes have to be greater than or equal to 20, right? This is the translation of that reality. So we've got to take a minute to digest that. I think that's the trickiest part of these. So number of fry servings, number of mashed potato servings has to be greater than or equal to 20. Right? That's meeting the minimum order. Now, that doesn't help us out very much. If we put it into mx plus b form, we could see that our y-intercept is 0 and 20, right? Like where it touches the y-axis. And the slope for this is -1 over 1. And so we could graph that out as a linear inequality, right? We could shade the half plane and graph that out. If we want a system of these, we have to graph another constraint. And so you've heard this word constraint before. When I said in the last section, we often have constraints of things being in the positive realm. So x is greater than or equal to 0 and y is greater than or equal to 0. This is the case here. We're only going to be dealing in that positive quadrant because we can't have a negative number of mashed potato servings. Not in reality anyway. So the next constraint is that there's only 30 potatoes available. So this is where you get into this sort of ratio of the fries using 1 potato and the mashed potatoes using 2 potatoes. So the sum of potatoes used in these potato dishes has to be less than or equal to 30, right? Because we only have 30 potatoes available. Taking this constraint and putting it into mx plus b form, we could see that our y-intercept is 0 and 15, and our slope is -1 over 1. So if I were to graph that, I'm going to do it really, really roughly because it's also graphed down below. So we're not up to the 20, we're up to about the 15, and we have the same slope on that line. So basically where the two half planes intersect, or overlap I should say, is the region that it's possible to produce a certain number of fry servings and mashed potato servings. If the daily orders max that out, things are going to go wrong. You're not going to serve enough plates or you're going to run out of potatoes. And so that's the reality, made very, very mathy, I will admit. So a much prettier picture of it here is a little different. We'll just take that. Oh, I shaded the wrong sides. Look at that. Sorry about that. So we've got the 20 slope up here. Sorry about that. And then the other one down here, this is the region in the middle. I'll just do it in black or something so we can see it. This region down here is the possible, right? This is where things could work. So in answering these questions and applying our understanding, if you as the chef make 20 servings of fries, how many mashed potatoes could you make? So you could read off here, right? If we make 20 potatoes servings, we're going to make 0 servings of mash. So remember, fries are on the bottom. That's where the F, right? And mashed is on the Y. And so at 20 on the X, we've got 0 on the Y. Same thing reading off the graph. If the chef makes 5 servings of mashed potatoes, what's the highest number of fries that they can make? So you read over here, the highest number of fries they can make is 20, right? We can read that off the graph. That would be really hard to do without the graph to look at. So the last one here, 20 people come into the restaurant, 15 people want mashed potatoes. So we got 15 people wanting mashed potatoes. Are there enough supplies for the rest to have fries? No, those 5 people are going to go hungry. That's not within the realm of possibility, right? All the way up here, you're above what is possible for satisfying those 2 constraints at the same time. And so that's really what we're talking about with this. Sorry, I shaded the wrong side of the half plane in my sketchy picture. I wasn't paying attention that closely. And these are the kinds of applications of these. We're going to start simple on these and build them up. I think these are maybe the hardest things that we've been doing so far. So do use the blue pages as your practice, and then use the practice test as an indicator of what the test question is going to be like. I tried to make these broken down into lots of parts so you get lots of part marks. The first thing you get a mark for is telling me what is X representing and what is Y representing. So this small business has a budget of $800 for their employees. That's going to be one of my constraints. A manager earns $30 an hour and a worker earns $20 an hour. So basically this question is about managers and workers. I'm going to say managers are X and workers are Y. That is an arbitrary decision. I just decided that. And so you can do whichever way you want, but tell me so that I know how to look at your work. The other thing here that I know is that managers make 30 bucks an hour and workers make 20 bucks an hour. So I like sorting my information. I like having a place to stop, because as soon as I read this, I think, holy heck, I don't know how to do this question at all. But if I break it down slowly, I could kind of work things out. One thing that you could do when you're trying to come up with your constraints, you're coming up with your equations that you could put on the graph, is say that X has to be greater than or equal to 0. And Y has to be greater than or equal to 0. We can't have a negative number of people. The other thing you could do is start labeling your graph. So the x-axis is going to be about the number of managers, and the Y is going to be about the number of workers. Okay, so in reality, there are limitations, right? So they have a budget of $800 an hour for all of their employees. So 30 times the number of managers plus 20 times the number of workers has to be less than or equal to $800 an hour. And this is a big deal to try and generate that. Hopefully we'll have enough practice. Because this is what we can turn into MX plus B form, and we can actually put on the graph. This question's simple because we only have one real constraint. We have these other ones up here as well, right? Not a bad idea to do. But what we need to do with this is put it in MX plus B form. I haven't put the numbers on here yet because I don't know what I need to graph just yet. So I'd have 20y is less than or equal to negative 30x plus 800. Giant numbers, but hopefully reasonable math. So y would equal, or sorry, be less than or equal to negative 3 halves x, a lot of fraction math in there, right? Reducing it to a fraction because I can see that as slope. And then 800 divided by 20 gives me plus 40. So what we have here is my y-intercept is 0 and 40, and my slope is negative 3 over 2. So I'm going to say this is 10, 20, 30, 40 workers, and 10, 20, 30, 40 managers. I have a feeling we don't want 40 managers and no workers, but we'll just see what the math says here. So if I start at 0 and 40, I could go down 3, and I'm going to go down 3 big units. You could go down 3 little ones if you wanted, 1, 2, 3, and over 2. This gives me just a bigger one. It's harder for me to count 1, 2, 3, and over 2, but they should all end up on the same line. This is, if I can do it neatly enough, should be a straight line, more or less, there. And then this half plane business. This is a simpler question. We're going to have the y values smaller than my line here. So this is a region that represents the possible human resource combinations for this company. Now, I don't know if this is truly an optimization problem, because I certainly wouldn't want, 20 workers or 20 managers and 10 workers. I don't think that that's super practical, even though that's a point on the graph, right? But it does give us, a way to meet this constraint of $800 per hour for all our employees. So that's a start in working up these word problems. The next one says that an appliance store has a goal of making $200 profit per day, probably to cover their minimum costs. They sell toasters and they sell coffee makers. I'm going to say X is toasters and Y is the number of coffee makers. I'm going to not call them brewers, I'm going to call them coffee pots. So toasters down here, and it's the number of toasters, and the number of coffee pots up here. Okay, so I've done some good work so far. The next bit of this is that we've got $15 profit on those toasters. So it's $15 profit each. And the next one, the coffee pots, are a $10 profit each. So if I were to craft this into an equation, what they make off toasters is 15 times the number of toasters that they sell. And what they make off of coffee pots is 10 times the number of coffee pots that they sell, right? This is all about the profit. I know that my constraint says that they have to make at least $200 a day. So that could be greater than or equal to $200. They can make more than $200, right? But they can't make less. So here we have the equation that's going to govern this. The other constraint is that probably X should be greater than or equal to 0, and Y should be greater than or equal to 0. And this is a really common constraint. If you write it, that's great. If you don't bother, I'm okay with that too. So now that we have this, which is probably the hardest thing to do, we need to, and even if we get this wrong, try and put it in mx plus b form, because that's how we get inequalities on the graph. These problems, as I was making them up, was really hard to keep the numbers small. So be patient. I tried to make everything work out nicely for us. We'd have negative 3 halves x plus 20. So this tells me my y-intercept is going to be 0 and 20, and my slope is going to be negative 3 over 2. Same slope as above. Weird. Okay, so we could change the scale up here. I'm going to make it as big as possible. If you make it smaller, it's not wrong, but I'm going to go 5, 10, 15, 20. And so as to not distort things, I want to keep the same scale on the bottom. Okay, so my y-intercept as an ordered pair is up here, and this tells me the slope go down 3 and over 2. So I could go there, or I could go down 3 big ones and over 2 big ones, right? Should be the same thing. I have an equal to sign part of my inequality. Even though this graph looks like the other one, the numbers are different. And the idea here is that we do have the half plane. Whoops, what did I do wrong? Oh, that doesn't make any sense. Oh, I get it. Y is above. I shaded the wrong half plane of my graph. So basically this is a minimum, right? We don't have another constraint. I just assumed it was going to be the lower side of my graph, and it is not. Surprise. And so this represents the possible realm. I mean, they can make, like I said, a whole lot more money, right? But this would be the minimum number that they had to make or they had to sell, and in combination. So if they sold 10 toasters, they'd all have to sell 5 coffee pots. If they sold, the 20 coffee pots, they wouldn't have to sell any toasters. Up here, these would all exceed their profits for the day. So any combination out on this half of the shaded plane is going to make their minimum. It's going to exceed their minimum, but this constraint is going to be satisfied. Okay, so let's take a look at another one. So this time we have a pottery studio, and they make custom bowls and teapots. So it gives me a little bit here. I'm going to say that X are those custom bowls and Y are the custom teapots. There is a labor requirement for these, so not $1 per hour or a profit, but 10 hours of labor for a bowl and 20 hours of labor for a custom teapot. Now, the constraint, the thing that is limited here, is the number of hours available. So what's going on with this is that we have 10 times the number of bowls, that would be the total number of hours contributed towards bowls, and 20 times Y is the number of hours put towards teapots, has to be less than or equal to 300 hours. We can't have more than that, or we've exceeded the number of hours the workers are available, and we probably don't want to have to pay overtime. So with this, there's another thing. So that is my one constraint. I also have some minimum orders here. So the number of bowls, X has to be greater than or equal to 10 to meet my minimum order. And Y has to be greater than or equal to 5 to meet my minimum order. And so I have actually 1, 2, 3 constraints for this one. Now, these two are the simpler ones to graph, right? I know that X is going to be my number of bowls and Y is going to be my number of teapots. Let's put this one into mx plus b so we can figure out the scales along the side. So I'm going to start by subtracting 10x from both sides. I get 20y is less than or equal to negative 10x plus 300. Divide by 20 everywhere. Numbers are big. Hopefully you're patient with the fraction math and go all the way. This tells me then I have a y-intercept of 0 and 15 and a slope of negative 1 over 2. So I could go 5, 10, 15, 20 up the side, and I'd have to match that scale down along the bottom so I don't skew the way this looks. And I'd start at my intercept and I'd go down 1 and over 2. Down 1, over 2. I went to the big ones because it's easier for me to count. And the half plane that's relevant here are the y values that are smaller than my line. I'm nervous after that last one. It's funny what mistakes I can make while I'm not explaining it to somebody, and then when I'm making the videos, that's when I catch my mistakes, when you say things out loud. Okay, so I've done the hard one here of my constraint, right? This original one here, that was the hard one to do. The other two constraints were the easier ones, right? So I'm going to have a line at x equaling 10. And what this is saying is the x values have to be greater. I can have more than 10 bowls, but I have to have at least 10 bowls. So I'm going to shade this side of that line in finishing up that second constraint. The next thing I'm going to do is this last one. So I'm going to have a line at y equaling 5. Well, that was a really good line. Okay. And then I'm going to highlight what it says. I want the y values that are bigger than that line. So basically everything above this is bigger than that line. So the answer to this, the production ranges that are possible for this pottery studio would be everything inside this little triangle. If an ordered pair is outside this triangle, it's not going to meet the restraints or the constraints or restrictions on this pottery studio, on this business. So we're going to step it up one more. A cleaning company offers regular cleaning sessions, and I said this is X, so X is the regular sessions, and Y are going to be the deep cleaning. Regular sessions take 15 hours of work, and deep cleaning take 20 hours. So nothing wrong with just taking notes as you read through the question. I cannot read these and then just nail the equation. So use it as a process. Write down what you're reading and see what you can build up. So we do have a limit here, right? We're limited to 300 hours per week. So if I were to build this into an equation, 15 times X is representing how many hours are devoted to regular sessions. And 20 times Y is how many hours are devoted to the deep cleaning sessions. That has to be less than or equal to 300 hours, right? This is the constraint. This is the limitation. The other thing that it says is the capacity is limited to a total of 18 sessions. So X plus Y has to be less than or equal to 18, right? We have two different constraints here, right? So it goes on here. There's another limit, 18 sessions. There are some more limitations here if we keep reading. So existing orders, so current clients, we have at least 4 regular sessions. So X has to be greater than or equal to 4. And Y, the deep clean sessions, has another constraint that Y has to be greater than or equal to 3. So this word problem has actually given us 4 different constraints that we have to graph. So I'm going to start by turning these two specifically into mx plus b form, right? My graph is going to have regular sessions down here. So the number of regular sessions. Oops. And the number of deep clean up here. Let's do the math. So we subtract 15x from both sides. That'd give me 20y is less than or equal to negative 15x plus 300. Divide by 20, divide by 20. I'm pretty sure that in the real world, the numbers don't always work out this easily. We'd have negative 3/4 x. Take a minute on the fraction math there. 15's divided by 5 and 4's divided by 5. So in lowest terms, that fraction is 3/4, and it's a negative, plus 15. So this is going to tell me that I have to go up to at least 15 on my y-axis. So I'm going to graph this, but before I label my axes, I'm going to finish up with this one. I'd subtract x from both sides. I'd have y less than or equal to negative x plus 18. So that one tells me now, if I graph this one first, it has the higher x or y intercept. So I could go 5, 10, 15, and 20. This one that I'm graphing first has an intercept of 18, and it tells me to go down 1 and over 1, down 1, over 1. You could go down 1 and over 1. They should all end up on that line. So if I draw this line, ooh, that's a good line, and shade the half plane. The y values are going to be smaller than my line. It's everywhere down on this side. The other equation, now that I've got it in slope-intercept form, my intercept is 15, and this tells me to go down 3 and over 4. So you can go down 3 little ones and over 4 little ones. Did I get there? Or go down 3 big ones and over 4 big ones. So those make it easier for me to hit the target. Whoa, that is actually pretty good. So graphing this second one should look something like that. And again with this, when I shade the half plane, it's everything below the line I just drew. So you can see it overlaps quite a bit with my first equation, right? So I've got a pretty big region there. The last thing to do is to graph these last two constraints. So I can see that x has to be at least 4. So that would be there. And I know that it's going to be everything on that side. And y has to be at least 3. And so it's going to be everything above. So I skip the highlighters. It's this funky shape, almost a triangle, but not quite, that represents the possible number of regular and deep cleaning sessions that this company can accept in a week in order to, meet all of their constraints, because that's important to keep a business above water. Okay, if you're finding these a little tricky, you are in good company. Remember that you can break it down. I'm fully going to anticipate problems in getting everything, so there's a lot of rewards for getting part way in this stuff. So this last one, it looks bigger. The math is a little bit harder, and I found kind of pulling out the equations a little bit trickier on this one. So I found this question and then I rewrote it like 3 different times because the first time I wrote it was actually impossible. So I think this one works now. A company produces item A and item B. So I'm going to say item A is going to be on my X and item B is going to be on my Y. So this is going to be B, and then make this just a little bit smaller. This is going to be item A. Okay, so it costs a certain amount to produce these things, and these things come with a certain profit. So basically, I'm going to have a constraint that is about cost and a constraint that is about profit. I'm going to assume that I am in the positive realm, which I think is a worthwhile assumption. And if you're making that assumption, go ahead and write it down. I will reward you with marks on the test. The costs have to be below $2,400. So item A costs $5. So each item that you produce costs $5. And each item of B costs $15. I was going to do this with A's and B's, and I found that it was just actually easier to make it more like what we have been doing into the X's and the Y's. So it has to be below. This is the cost, this is the bad thing. You don't want it to cost too much. We want a minimum amount of cost. So $2,400. We want it less than that. That's how much it's going to cost you. The profit, if I keep reading this, so profit A is $20. This is how much we're going to make. This is the sad face. This is the happy face, right? We'd have $20 on X and $30 on Y. And we have a goal. We want to make more than $1,200. So at this point, I have done almost all of the math, right? I've done this translating and made my equations. What I need to do now is try and get these on the graph. Even if you get the wrong equations, but you put your equations on the graph, I feel like that is a worthwhile thing to reward. So putting this into mx plus b form, I'd subtract 5x from both sides. And so I'd have 15y is less than or equal to negative 5x plus 2,400. I'm going to make this a bit bigger again, sorry. Divide by 15. I get that y is less than or equal to negative 1/3 x plus, and I did this on my calculator, 160. This is the, I'm going to switch colors. This is the constraint, but this is useful to me, right? I can see my y-intercept. I can see my slope. I can put that on the graph. Let's do the same treatment to the other one because I need to know how to number my scale here a little bit. Okay, so with this one, I have to subtract 20x from both sides. I'd have 30y is greater than or equal to negative 20x. Oh, what am I doing? Goodness sakes, too many videos today. Plus, there we go, 1200. Divide by 30, divide by 30. I get y is greater than or equal to negative 2/3 x plus 40. So I need, right, if I do the same thing here, I've got my constraint and I've put that constraint in mx plus b form. I'm going to have to go up to at least 160 on my axes here. So I'm going to go 20, 40, 60. My 40 looks like a 90, sorry. I'm going to do the same down the other side. We're going to do a unit on statistics and graphing later, and you want to make sure that you've got the same scales here if you're going to pull useful information off of this. Okay, so this first equation, that first constraint, had a y-intercept of 160. The slope tells me to go down 1 and over 3. I went down the big ones because it's much easier for me to do with my sketchy drawing tool. So here we have our constraint. It's way up there, and it's everything below this line, basically. Okay, so let's go through. That's going to take me forever to color in. It's a big, shady, yellow plane. Okay, so the other one, if I go back to it, it has a y-intercept of 40, and it tells me to go down 2 and over 3. The half plane that I'm shading is above this line, right? And so if I shade everything that's above this line, I mean, it would be everything here. But the key thing is that it's everything between these two lines is a pretty generous range of where this company can successfully operate, right? By minimizing their cost and maximizing their profit. Maybe they could tighten those numbers up to tighten in and optimize their company. So do take a look at the homework and the practice test for these. If you're having trouble translating into the equations, it's usually the problem. Like once you get the equation, putting it in mx plus b is something we've done so much. It's usually pretty good. But do talk to us to see if we can help you out with that anymore, because that's the end of Unit C.